Hello everybody and welcome to another exciting edition of Wide World of Reversible Reaction Sports. Today, the World Championships in Equiball. And to set the stage down on the floor, veteran color commentator, over to you, Jerry.
Right, Kevin. In Equiball, two competitors attempt to overcome each other in a canny game of strategy, dexterity and speed. These are Equiballs, purple representing iodine atoms, white hydrogen atoms. As the athletes warm up, I'll review the rules of the game. Competitor 1 attempts to separate all her hydrogen and iodine molecules, reconnect them to opposite colours, forming hydrogen iodide molecules, and toss them over the net to her opponent. Her opponent must attempt to reverse the process and toss the recreated original molecules back across the net. Game continues until equilibrium is reached, that point where both athletes are tossing pairs of Equiballs across the net at an equal rate. And that's when the whistle is blown and the set is over. A count is taken to see who has the least pairs left on his side of the net. That person wins the set. 2 out of 3 sets takes the game and the World Championship. Back to you, Kevin.
Thanks, Jerry. Now the action is just about to get underway because Amy has won the coin toss, and that means she's going to send from the reaction side. Andy then is going to defend from the product side. And there's
in this game, Amy represents the forward reaction and Andy represents the reverse. Because the initial concentrations of hydrogen and iodine gas are high, the forward reaction starts rapidly, and the reverse reaction rate is minimal, as no hydrogen iodide exists at the start.
To initiate, the receiver on the product side must wait until he's got 2 HI molecules before he can return the serve.
Oh, Andy's finally underway. There's a hydrogen and an iodine molecule ready for the return serve. Oh, the thunderous volley. He was amazing quick on the return. He certainly earned the nickname Quick, and that's because he has to take apart 2 HI molecules before he can put the hydrogen molecule together and the iodine molecule together, and then send it back over there with a scintillating volley.
Kevin, after some furious action here, we seem to be near. Yes. We've reached the end of the first set.
So the first set ends in victory for Amy with Amy 8 and Andy 12.
Kevin, the initial forward serve happened so fast and kept happening at such a fast rate that by the time Andy was able to equal the rate of the forward serve with his return volley, there were more project hydrogen iodide molecules than the reactant hydrogen and iodine molecules.
Well, that's because Amy certainly has earned that nickname, Quick.
Kevin, they're ready to go in the second set.
And the second set is underway.
The decreasing concentrations of hydrogen and iodine gas cause a decrease in the forward reaction rate, while the increasing concentration of hydrogen iodide results at an increase in the reverse reaction rate. So we have the forward reaction slowing down and the reverse reaction speeding up.
The second round is over. Oh, Andy's really come on in the second set for a dramatic, very dramatic 6-14 victory.
The turning point of the second set came when Amy failed to get her trademark speedy initiation. The initial rate of the forward change was not as rapid as in the first set. This allowed Andy to rapidly equal the rate of the forward serve, his return volley. Back to you, Kevin.
Well, you could cut the tension in here with a half-filled circus balloon as the students are getting ready for the third and final set. It's the tiebreaker.
Finally, we will reach a point where the 2 reaction rates become equal and the equilibrium is established. At this point, the concentrations of all materials remain constant. The reactants are forming the product at exactly the same rate the product decomposes to form the reactants.
Equal to the rate of the forward serve. And the game is over. What a match, Jerry.
Right, Kevin, the final set ends in a draw. 5 iodine and 5 hydrogen molecules for a total of 10 for Amy and 10 hydrogen iodide molecules for Andy. The 2 athletes reached equilibrium when the number of reactant molecules and product molecules were the same. You rarely see a result like this, Kevin.
On behalf of everybody here at Chemistry Connections, this is me bidding you adieu.